I am going to go through, or we are going to go through today, 1.1, which is the real number system. And I will say that it's a little bit challenging writing on here sometimes, so I apologize if it's not super neat. I'll try my best, but it says 1.1, the real number system. And again, depending on which class you were in last year, how much you did, some of this stuff might feel like review, and for other people it might be completely brand new. But we're going to start with, well, the real number system. I'm going to show you using a diagram. So if we have a large rectangle like this, this is the thing that I'm going to call the real number system. So, well, maybe I'll rewrite it here. So these would be all real numbers. Real numbers pretty much include everything, or all the numbers or values that we always work with, like fractions, decimals, negatives, positives, square roots, everything. The only thing that wouldn't be a real number, for example, we would call an imaginary number. And we don't actually need to worry about this, but I just think sometimes it's nice to know everything when you're learning it, or to at least be introduced to it. Does anybody know what an imaginary number is? It just sounds strange even, but anybody know or heard of that before? Okay, let me give you a really clear example. Do you know the square root of 25? Everybody? What's the square root of 25? You can just call it out. 5. How about the square root of negative 25? What is that? Can we do that? We can't do it. What's the reason that we can't do square root of negative 25? Thanks, David. So negative 5 times negative 5, because that's probably what you would think of when you see this, that actually gives you a positive answer. So there is no way that you could take some number, multiply it by itself, and get negative 25 as an answer. So that's why this is an imaginary number, because you actually can't do this. Everything else, anything that can be done, doesn't matter how ugly it looks, how big it is, it's called a real number. So within the real numbers, there's actually two different types of real numbers that we could have. So I'm going to split this down here, and we could have something called irrational numbers. And over here we would have rational numbers. And I will say this, you have this exact box or something close to it in your book in section 1.1, so it's up to you. If you want to copy it down, you can. And if you want to just look at that and throw in some examples into there, that's also okay. Okay, so irrational numbers, does anybody know or have you seen, I'm going to put this in a different color, this little symbol here. What is that? Yeah, pi. What's the deal with pi? How come it has its own symbol? What is it around, like approximately equal to? 3.14. Everybody good with that? And you kind of know that from last year. But it's not actually just 3.14. What is it really? Yeah. Good. So the number actually keeps going. We approximate it or we cut it off at around 3.14, but it even has its own button on your calculator because it's 3.1419, da 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 da. It keeps going on and on and on, and the digits don't repeat and it doesn't terminate or end. So that's why it has its own symbol. That's an example of an irrational number. Another example of an irrational number would be something like the square root of 3. If you were to take square root of 3, punch that into your calculator, you would find it would punch out or spit out a decimal answer where the numbers keep going, it doesn't get cut off, and it doesn't repeat. So there's some examples, and that one's not quite as common. So we call them irrational numbers. There's another one that you probably won't see till about grade 12. You might see it in grade 11, but it sort of looks like an italicized E. It has a symbol. It's just like pi. It's approximately 2.78, and that is called Euler's number, and it has the same properties as pi. So it doesn't terminate or stop. The decimals keep going, and they don't repeat. Okay, so then when we look at rational numbers, there's a few different types. I'm going to draw some more boxes in here. So from our rational numbers, in the first box, we have something called integers. Anybody know any examples of integers? Yeah. 1. What else? What's weird about integers? So positive numbers, yes. What else is included or counts? Negative numbers. So let's say we have -5, +3, and I'm going to put ... So basically we can have positives and negatives, but they have to be whole numbers. That counts as an integer. Did you know that one from before? And probably did some of it last year. Okay, so then let's go in another box. So basically the further in that we go, the more exclusive we're becoming. So we're leaving out some numbers from the definition. We're getting pickier as we go in. Does that make sense? So an integer is a rational number, but not all rational numbers are integers. Do you get that subtle difference? Okay, so the next one as we go in are called whole numbers, and I'm getting lazy and just putting the symbol. Any idea as to what whole numbers means? What's the difference, or you could look at it and say, what's the difference between integers and whole numbers? Yeah. Whole numbers are all positive, but we also can start at 0. So 0, 1, 2, ... and it keeps going. So basically, as we moved in from integers, we dropped off the negatives and we start at 0. Yes? Yeah, so then the next one in, as we go in, I'm going to draw another box here, is natural numbers. And what helps me to remember this is I think of how we naturally count. If I wanted to naturally count the number of people in this room, would I ever start with 0? We start with 1. So 1, 2, 3, and on and on. So that's what natural numbers represent. So I drop off the 0 and I start with 1, 2, 3, ... and we keep going. So you can see the pattern. At the further in that we go, the pickier we are becoming, or we're dropping off or leaving some things off. So integers, whole numbers, natural numbers, they are all rational numbers, but not all rational numbers are natural numbers, right? So it's a little bit picky. It requires a little bit of thinking, but that's basically it for this section. So I'm going to have you go to 1.1, and I'm going to have you do, so I'll write it down here. So for section 1.1, you're going to do numbers 1 to 3, all of them. And actually, let's do odd letters. And I'm going to explain to you what odd letters means. That means you do, I'll explain it over here. You do the first one, A, and then you'd skip the next one and you do C, E, and on and on and on. So you do the first one and then you alternate. Does that make sense? So you're doing about half of them.